right. And with that, we're live. Morning, everybody. Morning, William.
That was really a soothing intro.
I know I'm a lot calmer now, thanks to that pleasant music.
Can we see it again? Just loop it a couple more times.
Later. Yeah, well, so welcome to our first, but not last ever, Enterprise Linkerd webinar. I'm Jason. I am a technical evangelist for Buoyant, and we're joined by William.
Hello, I'm William. I am the CEO of Buoyant and the maintainer of Linkerd's README.
Great. And today, William, what are we talking about?
Today we're going to be talking a little bit about Linkerd Enterprise, which is a relatively new, very new actually, distribution of Linkerd. Not open source, it is proprietary, so let's just get that out of the way. But I figured, we're going to keep this short and sweet. We got kind of a couple slides about Linkerd and the differences between what's in open source and what's in enterprise, and then we're going to have a fun demo, so I hear, from not yours truly, from others truly.
This guy. And folks, while you're here, go ahead. If you're in the Linkerd Slack, you can message us over in the workshops channel. Also, feel free to use the chat in whatever platform you're watching this in, and we can read off your questions. The more you ask questions, the more we can make this interactive and directly address things that you want to talk about. So please feel free to send us messages, and I'll try and interrupt William with questions as we go. Sound good?
Sounds great to me, Jason.
Great.
Yeah, please do interrupt me. I'm gonna try and keep it short and simple. But yeah, happy to make it more of a conversation and less of me just talking and talking. All right, so let's get started. I'm going to do a tiny intro to Linkerd just in case someone from the distant future, archive the USB finds like a USB drive buried under the ground and is like, oh, what is this? So Linkerd is an open source service mesh, right? Security, very security focused, whole host of great adopters here and really healthy, active community. We just hit 9,500 people on the Slack channel. So 10K will be coming soon. Tons of GitHub stars and so on. That's the CNCF graduated project. Now Linkerd was created by Buoyant, which is a company that I run, and Buoyant continues to be kind of the primary sponsor, and we're also the ones who created Linkerd Enterprise. So if you are very confused, or you're a traveler from the far future and you're wondering what a service mesh is, the idea is basically you have a set of functionality. You don't want it as part of your application. It kind of belongs as part of your platform. And so you stick it next to your services. And in Kubernetes terms, what that means is you run it as a sidecar in the same pod, and the communication goes between application components, gets mediated by those sidecar proxies. And by adding these proxies, we can add all sorts of interesting functionality while keeping everything transparent to the application. Now, there's other approaches. Linkerd has, in fact, done other approaches that don't involve sidecars. There's a very interesting conversation we can have. But at least today, sidecars continue to be the best way to deliver this functionality. And it's a way that Linkerd is very, very good at. And so what kind of features does it provide? Security, observability, reliability. Like I said, at a platform level, no code changes required, with maybe one or two minor exceptions. And this is owned and controlled by the platform team. Now, one really interesting thing, this is like a new graphic that if you're going to be joining us at KubeCon in Chicago next month, we'll have some stickers you can take home too. Keep our planet safe and clean, crush all memory safety bugs. So there's Linky on the left, which is a Linkerd mascot. And I don't know what the name of the Rust mascot is, but the old crab guy, we'll call him Krabby, is the mascot of a language called Rust. And Rust is a huge part of Linkerd. And in fact, that's kind of our primary differentiator, is that almost every service mesh uses Envoy under the hood. Linkerd does not. Linkerd uses a Rust-based micro proxy. And I wrote a long article about all the decisions why. But this continues to be kind of the thing that really makes Linkerd special. First of all, Rust allows us to avoid the entire class of memory vulnerabilities that are endemic to languages like C and C++, which of course Envoy is written in. Rust compiles directly in native code to get something very, very fast. You have the most modern, most interesting, all of the state-of-the-art work that's happening today in network programming is all happening in Rust. So we get to make use of this amazing ecosystem of libraries like Tokyo and Hyper and the rest of the modern Rust asynchronous networking stack. And all of that goes directly into the proxy. I wrote a really interesting article, I think, last week. I don't know if it's interesting. I wrote an article last week about something that I thought was interesting, which was that, there's this very widely distributed CVE that everyone was talking about a DDoS attack, distributed denial of service attack on HTTP2. There's an article from Cloudflare about it and Google, and everyone was kind of getting bit by this thing. Linkerd has been immune to that since 6 months ago, 6 months before this became a big deal, because of the way that Rust works and because of the security consciousness of the Rust ecosystem. So you get all these benefits from being in Rust. And really the biggest benefit in my mind is to you, the user, you don't have to care about this. So I like to talk about it, but you shouldn't actually care. The proxy should be an implementation detail, and that's the thing that really sets Linkerd aside. I found this a really fun article. 70% of all security bugs are memory safety issues. Okay, well, if that's the case, then why are you writing your proxy in a non-secure language? Okay, right. All right, I'll run this through this real quick because we're all kind of hopefully on the same page. Big use case for Linkerd is mutual TLS. Another big use case is cross-cluster communication. Another big use case is authorization policy. So all these reliability and security features we can give you out of the box. Very briefly on the open source roadmap, and I want to talk about this because, I want to emphasize, the open source project continues unaffected. The enterprise distribution only helps open source. So we hit 2.14 a month or two ago, which delivered kind of pod-to-pod multi-cluster, a new type of multi-cluster really focused on enterprise use cases. That's purely in the open source. 2.15, our upcoming release will add mesh expansion. Really exciting, really powerful capability for Linkerd to add the data plane outside of the mesh. So you can have the data plane on VMs and non-Kubernetes workloads and bring those into the mesh. That's all on open source. And then 2.16, we're going to tackle ingress and egress. So a lot of really exciting stuff coming up on the open source roadmap. So if all that is so great, Jason, then why are we talking about Linkerd Enterprise?
It's a good question, Ryan.
Yeah, thanks. So the idea here basically is that, and Dominic pasted in my blog post in the workshops channel. So thank you for that, Dominic. Really appreciate that. So the idea is here we want to have a distribution that is focused on the very unique needs of enterprise customers, which are weird and strange, but this is something that we can address in a really efficient way with an enterprise distribution. So we want to stick as closely as we can to open source Linkerd, all right? But we're going to add a couple of things on top. We're going to build the images in a separate build chain that has a set of additional protections and a set of additional tests that allows us to do things in very customer-specific ways. We're going to allow ourselves to sign up for SLAs around CVE remediation, which is hard to do in open source, but once you control every aspect of the build chain, you can. We're going to ship things like SBOMs, a whole bunch of other kind of what I would call bitstream assurance, things in enterprise. And then we also have an opportunity now to start adding some interesting enterprise-only features. FIPS 142 and 3 compliance is one of them. If you are selling things to the U.S. federal government, that's really, really important. If you're not, then trust me, you don't want to know anything about this because it's horrible and difficult, but also mandatory. Lifecycle automation is a really fun one. So we can automate installs, upgrades, rollbacks, all that stuff in a purely, in a purely automated and GitOps compatible fashion. Cost optimizing routing is probably the most interesting feature in my mind that we have right now. Of course, there's a whole roadmap ahead of us. This is what Jason's going to demonstrate as soon as I finally shut up. And this is a way of routing traffic in a way that avoids sending things across zones unless Linkerd needs to for HA reasons. And the reason that's important is because if you have a lot of traffic and you're in the cloud, you get charged money for cross-zone traffic. So we can kind of give you the best of both worlds. But I'll let Jason talk about that. Okay, cost optimizing routing. We're going to see the demo for this very soon. Basically, for some of our customers, we're talking millions of dollars a month, and we can cut that by at least 50% right off the bat. On the left is like the visual, right? Here's all the cross-zone traffic. On the right, the world you want to be. And the approach also works, and this is interesting, across clusters. So if you have multi-cluster traffic that is sharing the same zones, we can preserve the zone affinity across clusters. So that turns out to be really important for some customers. I've got some really interesting graphs that I would love to talk about because the way this works is so interesting. I might leave it for, maybe I'll say a few words and then Jason will give you the exciting bit. But basically the way we're going to do this is we're going to have a load band, okay, that defines kind of the expected behavior, right? This is a system when it's not stressed. We're going to measure the load. And when the system's not stressed, we're going to keep all of our traffic in the same zone, okay? When the system goes under stress, right, when things start failing or things start slowing down, then we're going to send traffic to other zones, right? And that way you get the best of both worlds. And we'll see this in the demo. You get the ability to have all the cost savings of single zone clusters, but when things start falling apart, you get all the HA benefits of running a multi-zone cluster, right? Like that's the point of having a multi-zone cluster in the first place. This is a really interesting feature in Linkerd Enterprise, and it's something that Oliver has been working on for like 6 months. He's in this happy place working on this stuff. If you are a deep Kubernetes nerd, you will immediately be asking yourself, what about topology hints? We looked long and hard at topology hints. They are very, very crude, and they cannot provide both HA and cross zone and single zone affinity at the same time. Really surprising. Basically, they filter endpoints at layer 4, so you get a set of IP addresses that have been kind of allocated across zones. Those get filtered. By the time you get to them, you only see endpoints in your zone, and that's it. And there's all sorts of conditions. So, if things go under stress, if traffic increases, there's really no responsiveness here at all. And in fact, you can't send traffic. Once you have this enabled, you can't send traffic across zones. You don't even have access to those endpoints. Really kind of surprising. But we'll see if the demo goes. If we have lots of time for the demo, we'll see a demo of this too, and all sorts of other kind of caveats here. So, this is a longer conversation. So basically, we can be a lot better. Is what it comes down to. All right, lifecycle automation. I kind of talked about this already. It's an operator that automates installs and upgrades, and fully compatible with your GitOps tool of choice. Policy generation, I'll just touch on it briefly. We're not going to see that today, but we can do a lot of interesting things around observing the traffic in your system, generating policies that allow you to capture what's already there. And this gives you a really nice way of bootstrapping into a fully zero trust environment. Linkerd's policy mechanisms are so expressive and so rich, but getting started can be not trivial. And of course, you get kind of all the enterprise features of Buoyant Cloud, which ranges from all sorts of health monitoring and alerting and kind of proactive warnings to security policy analysis and things like that. Support services. If you're paying us the big bucks for Linkerd Enterprise, and we're with you, and we're going to make sure this thing works for you. That's kind of the relationship that we're talking about here. Okay, so I think one more slide about roadmap. So what else is on the roadmap in Linkerd Enterprise? Okay, this is really just the beginning. This initial set of features is just the beginning. Other things we're really looking at, and again, these are what I would call enterprise problems, and I want to distinguish that from open source problems. A lot of these are what happens when you really have to manage this product at scale, and you have a company that has thousands of users, or thousands of employees, or tens of thousands of employees, or you've got a huge number of clusters. You've got 200 clusters, and you're trying to figure out how to manage that at scale, right? So managing some of the linking aspects of multi-cluster is definitely something we're discussing now. Policy automation, I think we can take the same policy generation and extend that out and make that a lot more flexible and capable of handling situations where you have thousands of developers who are trying to express policies that you don't want to teach them YAML. All that stuff is ripe for enterprise features. Canary-based control plane upgrades, JOT validation, Windows support. Believe it or not, I'm really excited about Windows support. Those are all things that are currently cooking in the big old soup pot of enterprise features. And you might be asking yourself at this point, oh my gosh, what does this mean for open source Linkerd? And basically nothing. I don't think we're trying to do this the right way. And I want to make sure that we don't ever do a disservice to the open source community just to get something in enterprise. Linkerd is the world's simplest, lightest, and fastest service mesh. That's a promise that we've made to everyone in the community. We're committed to keeping that promise. Enterprise gives us a mechanism to serve these kind of unique and special needs, but it doesn't detract from that core mission. And as I showed in the very beginning, we've got a really long and exciting and powerful roadmap for open source Linkerd, with mesh expansion, ingress, and a lot of other fun stuff. So all that stuff continues to be in the open source. So I said we, but really I at least am most I'm even more excited about Linkerd than I have been in the past.
So William, this doesn't mean then that we're taking Linkerd closed source, right?
No. Oh my gosh. Maybe I should have said that in the beginning. Were you confused about that, Jason?
No, I just like asking the question.
Yeah. Yeah, that's right. That's right. So Linkerd remains, and actually that's a great question, because I know there's weird stuff going on in the licensing world with HashiCorp and other companies. We have no intentions of doing any of that. Linkerd remains open source. It remains Apache v2. That's kind of that's kind of core to our ethos. Oliver and I have been using open source and contributing to open source and building open source for decades at this point. So yeah, great question. Linkerd Enterprise is a separate proprietary distribution, but all the money that goes into Linkerd Enterprise gets spent on the maintainers for open source Linkerd. So it's a win-win. All right. With that, I'll take a look at questions, Jason, while you get your demo ready to rock and roll. How's that sound?
Sounds great, but I'm already ready.
You're already ready. Wow.
I stay ready. And look, and I don't see a ton of questions in the chat, folks. If you do have questions, we'd love to hear them. Right, like the more you ask stuff, the more interactive we can be. So now we're getting into the demo portion. William, can you see that? Okay.
Yes, sir.
All right, so I've got a couple things going. In this top window, what you're seeing here is Linkerd telling you what pods are getting what traffic in the environment. And what you can see is I have, well, it's maybe hard to see, but what I've got is a traffic generator called Brush. And Brush sends requests over to the Paint service. And the Paint service is populated by pods in one of three deployments. We have blue, green, and red. Right, so each of those deployments has an affinity for a particular zone. Here I'm running a K3s cluster that has nodes that each are logically listed in their own availability zones. So AZ 1, 2, and 3 are A, B, and C. You remember what the zone annotation is. In the second window, this middle window, you can see what node each pod is running on. So every node represents an availability zone from the perspective of my cluster. And we can see that Brush here is running on the 0 node, and red is on the 0 node. So even though I have three availability zones, you can see the traffic is effectively balanced across all three pods. Right. So we're going to show you how we can use Linkerd's topology aware routing, Linkerd Enterprise, topology aware routing to do better than this. Okay.
This is kind of what you want.
This is what you want, right? But now I'm concerned about my cost, right? If 2/3 of my traffic is leaving my zone, and it doesn't have to, right? Then I'm incurring new costs that I don't need to incur. So I'm going to turn on cost-aware routing in my cluster, and I'm going to do that by adding an annotation to my Paint service that says, "Hey, I want you to be cost-aware." Now I've already put some annotations on the service that tell it how to balance it. What are my thresholds for this balancing? That is, what are the rules for when you should stay in zone and when you should leave the zone? And I'm gonna turn on cost awareness for this service. And what we're gonna see here is this traffic is gonna drain from blue and green and is gonna shift 100 requests per second into red. Right, so we'll slowly see red's RPS climbing while blue and green's RPS go down. And William, I see we have a question. If you look over,
right. So Jason, is that service a cluster IP or a load balancer?
It's a cluster IP service. All right. Yeah, so Chris Preslin asks about Linkerd and GitOps, right? Where they have an issue with, they'll have a setup where using a GitOps flow, they'll get pods that are provisioned before the Linkerd control plane is necessarily up and running, and they have to go through and delete the pods to force a roll. So that's actually a problem that the Linkerd operator handles for you. And we've got a whole thing on it. So if we get time to dive into that operator, I can actually show you how it handles it. Essentially, the data plane operator watches your pods. So you can tell it what pods you want to make sure are currently in sync with the control plane. And if those pods are meant to be injected, it will force them to get the proxy of the same version as the control plane. Same version, same config as your control plane at any given time. Right. So it does solve that order of operations problem they get. Now that I've gotten to talk a little bit, we can see that all our traffic is shifted over to our red service. So that means that red right now, the pods in zone A, are sufficient to handle the volume of traffic that I have. So I've shifted all that traffic to that zone. So I'm not crossing zones because I'm still hitting my performance targets for that application. But what happens when we get a surge of traffic? Well, let's look at that. We're going to edit our brush config to mimic an increase in traffic.
Brush is the traffic generator, right?
Yeah, brush is basically just a traffic generator. So what I've done is I've changed it from 100 requests per second to 300 requests per second. And what we're going to see, and in fact, we're already starting to see it, as red climbs, the latency climbed a little bit, and now we're starting to shed load over to other availability zones. So we see green and blue start to pick up some of that traffic that red can't handle. So what we want, why I'm running a cluster with 3 AZs, is I want that extra capacity to be there. And if I'm spending money on cross-zone traffic, I want it to buy me something. I don't want to just spend money because I'm naively routing around my cluster, right? I want to spend money because I need to for availability purposes. I need to for performance purposes, right? Or whatever that use case is. And we can see here that while the majority of the traffic is still going to red, right, we're starting to hit green and blue also, right, to make sure that we can scale up for this event. It's all making sense? William, looks good?
Looks great.
All right. Now let's fix it. Really, let's address it. So I've got deployments that are zone specific for my service. So we're going to go ahead and see what happens when we increase our capacity to meet the needs of our application. So let's do a scale, kubectl, scale, deploy, and we want to do red because we're in the red zone. So as we scale up red, what we're going to see is the new pods come online. Linkerd's proxy is smart enough to see that now it can route in zone, right? So the new red pods automatically get added to the load balancer, and we see that we're performing now well enough that we don't need to be leaving zone, right? So whether this is an autoscaler, hopefully it's an autoscaler, not a manual operation, but as that kicks in, I take the pressure off and I go back in zone. And now you see how we can automatically adjust for load, not lose anything during that spike, right? And then adjust back so we go to in zone. So now you're spending your money in a smarter way. You're getting more bang for your buck, and ultimately we're reducing our overall environmental impact, which is good for everybody. And yeah, that is the core of cost-aware routing. There's more to it. If you want to see more, I'd love the chance to talk to you about what you're doing in your environment and see if we can save you some money with Linkerd Enterprise.
And the real question, because as we've talked to our customers, some of them, like I said, are spending millions of dollars a month on this. Some of them are spending hundreds of dollars a month. So it really depends on what is the level of, the actual cost savings depends on what's the level of traffic that's going across zones. So if that's high, then probably you'll save a lot. And if it's not, or if you're running single zone clusters, well then, so it's not going to do a lot for you. So that's kind of the first question. for this specific feature.
So Chris asked another great question. Thank you so much for this, Chris. Will Linkerd Enterprise be significantly ahead or behind open source Linkerd? Can we expect releases in a similar time frame to the current OSS project? William, you want to answer that?
Yeah, that's a great question. So, I think it will be probably slightly behind, but I wouldn't make it significantly behind. So we'll probably linger a little bit, especially as we kind of build out the testing infrastructure and really start doing customer specific testing. But we're not going to be like versions behind.
Yeah, right. Essentially, what I tell folks when we talk to them is you're not going to see the .0, right? But you're going to see the .1 for every major release.
Yeah. Another question, and I'll ask this one for you, Jason, also from Chris. So thank you, Chris. Jason, can we also make this aware of external services? I think the cost-aware routing, aware of external services like Postgres. Could we prefer routing to pods running in the same zone as a Postgres instance?
Yeah, so this is where my answers go a bit weaselly, kind of, right? So you can't today. As we go to mesh expansion, right, and we look at how do we add things into the mesh that are running in VMs or in physical machines, then suddenly we can start taking advantage of this even through the rest of that estate. This also, by the way, doesn't just work in cluster, it works cross-cluster. So as you may or may not have seen, in 2.14, we gave you the ability to do direct pod-to-pod communication across clusters. This cost-aware routing is built to work with that. So we can go, as we cross clusters, we can keep that zone affinity going. If you're using like a managed service like AWS, whatever, unfortunately, there's no immediate plan to solve that.
Yeah, I think the other caveat maybe with Postgres is that the ability to be really dynamic when you're doing this is fairly specific to HTTP and gRPC, right? Because those are individual requests that the proxy can route and can decide which connection to send across. With Postgres, and other protocols that sometimes are connection specific, the proxy doesn't have that flexibility. So the starting point for us, at least, is gRPC and is HTTP traffic, where we can be very dynamic in how we send this request.
Yeah, great point, William. Thank you.
Well, great question, Chris. So thank you. Okay, well, this is cool. We kept this short because I didn't want this to be like an hour-long presentation, but I feel like we actually could have used another 10 minutes for demo. There's a lot more fun stuff to demo. So I guess where we'll leave it, in the interest of time, is there's a lot more here to show off, a lot more to talk about. So please reach out to Jason or reach out to me. We'd love to show off more of what we're doing here. I think it's really exciting. I think it's really cool. And I'd love to have a conversation with you folks about whether this makes sense.
Great.
I think we should wrap it up here, James. Jason. I think we should wrap it up here, Jason.
No problem. We only worked together 3 years. Don't need to learn all your employees' names.
Employee number 77. I think we could wrap it there.
Okay, folks. Thank you so much for taking the time to listen today. It's been great chatting. We really appreciate the questions. Have a good rest of your day.